Okay, here is a solution to problem 19. Let's take a look at trying to find the estimate to the distance traveled by using LRAM. In this case, we're going to have 10 intervals. The first rectangle in the LRAM is going to be have a width of 0.001, and its height, because I'm using LRAM, we're going to be always using the first of the two numbers. It's going to have a height of 0. Now, instead of writing 0.001 times 40 and 0.001 times 62 as I go through the list, I'm going to pretend right off the top of the bat that I've already factored out the 0.001 out, and each of these is going to be multiplied by the heights that would have been listed first in that interval. So 0 on the first interval, 40 on the second interval, 62 on the next interval, so on and so forth. Plus 108, plus 116, plus 125, plus 132, and I'm running out of space, plus 137. Now, when I add up those values, it looks like I get it looks like I get 1040, and if I multiply that by 0.001, it looks like I get 1.04 miles. Now, the thing about that is it left off the 142, but we know that we could do the RRAM 10. Again, the width of each rectangle would be 0.01, but this time we start at 40 and then 62, so on and so forth, and then we would end up including the 142 in the end. We know that that number I'm sorry, I got the wrong number here. This number here, I'm sorry, I'm working from some bad notes here, is 998, and this distance that includes the 0 is 0.898. If I do this one, this is the one that is 1040 and is a distance of 1.04. So this one is a little bit low because it includes the 0 and not the 142. This one is a little bit high because it doesn't include the 0 but includes the 142. And the last thing that we had talked about, using a trapezoidal estimator as well. The trapezoidal estimator is the average between the right and the left estimator. And if we do that, we end up with 0.9898 plus 1.04 divided by 2. And if we do that, we end up with 0.969 miles. And that is the value that they came up with. So they were looking at the average of the right and the left because that average includes both data points, the 0 and the 142. The next question is, how many seconds did it take to reach the halfway point? Well, the halfway point is half of 969, and that is 0.48 there. Okay. Um, and when do we reach that halfway point? Well, one way to look at this would be say, well, how far did we travel in this interval? Well, if we use if we use the average um, we could say that we traveled 40 times 0.01 in this interval using, let's say, a right-hand estimator, and at the end of one thousandth of a second, we are at 0.4 miles. Well, we're not halfway yet. How about when we go another hundredths of a thousandths of a second, we would add another 0.062, or our at the end of 0.002 seconds, we would be at time distance would be about 0.102. Still not halfway. How about when we're at 0.03? Well, again, using the right-hand estimator, we're going to be another 0.8 of a mile further. That would get us to 184. Still not halfway. How about the end of 4 seconds? How much further did we travel? A 0.096 of a mile. And if we add that 0.096 there, we're going to go there, carry the 1, 8, we're at 28 hundredths. Still not halfway. How about at the end of 5 seconds? We've traveled a little over a tenth, 0.005 seconds. In that next hundredth of a second, we traveled a little less than a tenth, and that gets us up to 0.388. Still not halfway. And then how much on that next interval? 0.116, 0.006. If we add the point there, we add that last bit, we end up with 4, carry the 1, the 0, carry the 1, 504. Okay, that gets us over the halfway point. So it looks like it took about 6/100ths of a second, 6/1000ths of a second, and at about that time we were traveling about 116 miles per hour.